Yeah. Okay. We're working on a project to model the impact of weather data on Yelp business reviews. Uh, Thank you for joining us. This project is my teammates are myself, Chaitanya, Babu, Vijay Prakash, and Hari Shankar. At the outset, we'll go over the outline of our presentation today. We'll talk a little bit about the background of our project and why we thought this project is a project that has some significance. We'll then talk about the specific objectives that we seek to accomplish through this project, uh, and our initial review of the Yelp API and the weather API datasets. We also looked at several Yelp machine learning projects on Kaggle. We also looked at some weather related projects on Kaggle. So this gave us an idea of what has been done before. And using that as a basis, we thought it would be a worthwhile pursuit to combine weather data with the Yelp API data so we could see if there was an impact of weather on the end reviews on businesses by customers. We also wanted to see where the gaps might be in terms of data collection and come up with a model for future data collection, or think about what other data sets we can combine to make our predictions more accurate. In terms of a background, uh, we looked at literature that indicates if weather has an impact on sentiment that's reflected in reviews, just to make sure we were tracking in the right direction. And we found a couple of publications to this effect that did suggest that the weather does have an impact on data. Specifically, this particular publication, which suggested that the offline context affects online reviews and the post effect consumption of weather. So there's literature there to suggest weather has an impact on how people perceive their experience at a particular business. We looked at a couple of other publications as well, and this frontier seasonal and weather effects on travel related mood and satisfaction. So there is definitely a body of literature that suggests weather and seasonality impact travel, mood, and business reviews that result from the travel. So we looked at predicting cumulative helpfulness in crowdsourced reviews, because that's the kind of data we have in the Yelp API. We then also looked at sentiment analysis and application of NLP models, because we think what we could do beyond the review is to classify the review and extract codes and keywords out of them and use that to further inform our model that combines weather with business reviews. So we looked at some of the Kaggle codebooks to get a review of the Yelp API itself. In our data analysis section, I will talk a little bit about the various data sets that are available as part of the Yelp API. And then we also looked at several different weather API. Weatherapi.com is a paid service for historical weather information. We also looked at the government's open API that's put together by the National Oceanographic NOAA. NOAA. It's put together by NOAA. And we think we can extract some of the data from there. So why is this problem significant? We think this analysis may help businesses identify reputational risk that is mediated by weather. So for instance, if we find families tend to be very sensitive to weather, or groups tend to be very sensitive to weather for on a certain kinds of business. We would then that business could then, if they have advanced booking for those parties and they knew the weather is going to be inclement, they can maybe make some arrangements to enhance their experience or advise them to come at good weather days. So at least that one, this can make the business more aware of travelers' preferences.
And it will useful for a business to improve their brand
Absolutely, the business can certainly improve their reputation. And the restaurants, so we all know our food choices are impacted sometimes by weather.
Yeah.
So you could have like special foods based on weather.
Maybe they will recommend some foods based on weather.
Yeah,
conditions.
cloudy, sunny, and they can have a weather-based menu.
Yeah.
Especially if you know that your restaurant, who might like what kind of food based on weather. Right? Who's more likely to be weather influenced. So it may be a good strategy for selling and generating revenue. Then we also think this analysis can show missing data that might be improved, that might be important to match users to the business.
Yeah.
So in terms of supposing somebody is very affected by pollution, and then they know that the weather in a certain place is going to be bad, and the forecast is like high humidity and pollution, then they know not to go and sit in an outdoor restaurant.
Yeah.
So we think that kind of matching preference for future travel we could look at. Right. And you can look at many spatio-temporal features because we got a very big data set with with Yelp. So we can look, and Yelp also classifies the businesses into several categories. So we can we'll talk a little bit more about that in the data analysis section. Then so we looked at what is the objective that we are trying to work on, right? So we're trying to model the impact of weather on the review sentiment. So this has many pieces to it. So first, of course, is the weather API. We have to do the extract, transform, and load the weather API from NOAA. A couple of ways we can do it. We can create our own like database in PostgreSQL, load all the data there, or we can directly do it in Pandas data frame. It really depends on the amount of data we have.
Based on dataset, we can import either on Excel or directly into the database.
Or create like our own relational data model and put this, because one of the outcomes of this project could be an advice on what kind of data model can add more value in terms of collections. That can be another. So then, another challenge is the weather data typically is recorded every hour. But the business review data, we only notice that they have the date and not the time. So we have to somehow do like some sort of pivot.
Businesses are limited to certain working hours.
They're limited to certain working hours. So we know the review happened between a certain window of time. So we have to collect the weather data for that window of time. And then maybe within that window, figure out what is the high temperature, low temperature, pollution range.
And then on particular temperature, what is the sales and how is the reviews?
Right. And so somehow we have to figure out, maybe we may have to have some scenarios. What if the review is written in the morning versus and then in the afternoon? And then we know if it's a restaurant, then we can guess that it's either dinner or lunch. So we may have to do some sort of transformation and coding as we do the analysis, because we're going from our review data is only recorded as a day, but we also, from the business, we have the time window, but the weather API gives us hourly data. Then so we have to now combine the Yelp API data and the weather API data. So basically, in the review table, we're going to append it with a set of features from the weather API, essentially. So the review table will also be appended with the estimated review time based on business hours and user features, right? So this is a data point that's missing. We think this could be a potential limitation. but you still are in the same day, you're in the same season, and the weather range may not be that much through the day, but we'll have to see from our initial analysis. Then ultimately, we'll use this data set to generate machine learning models using combined feature set and then test the performance. So we plan to, because we think we have like a huge data set, we think we can optimize different ML models for different businesses, and we can optimize. And also, some business types in some cities may have sparse data. Similar business types in other cities may have lots of data, or within the same city, a particular type of business may have a lot of data, and a different business may have less data, but they could be closely related businesses. So we think there's an opportunity to implement transfer learning, where we can learn from one data set, take that model, and then use a different target data set and test to see how that model performs. And so we're looking at implementing a federated transfer learning to see if that increases the prediction. And so we'll have to implement, so because we're going to have so many different models and all of us will be working on different models, we think we need to have like proper MLOps infrastructure, and we chose like Databricks, Google Cloud Platform,
GCP,
and
then some what we call
like lake house, like a data lake, and then
if possible we can use our own database in MLOps.
We can use our own SQL database to hold it in MLOps. So that those are things we're going to learn.
It has transparency, like
right. We can transfer that knowledge easily.
In group we can transfer.
Correct. Because we're a group, we're all in different places, so we can actually use MLOps and then
like an machine learning project management
like a tool. So we can work on that. So these are based on that, these are our study objectives and research questions. Combine. So one of the objectives is to combine Yelp and weather data using some sort of conditional logic. This also means we may be able to combine other data sets, not just weather, but there may be other data sets that we could potentially combine down the road. Then one of the questions we're asking is, do weather-related features impact review for certain visitor profiles, like people who are single versus groups? And that's data that's already there in the Yelp data set. Can we predict ratings change based on weather? In other words, is weather a real factor in the rating for certain thing? And then can we create a set of derived features like good weather, bad weather, moderate weather, and see if there's some thresholds beyond which weather matters? Then is there any ideal weather feature set for specific type of business? So this way we know, hey, if you're launching this business, if you're in this kind of place this season, you're likely to do well. And this may have some importance because of the changing, global weather patterns. Maybe something useful to know. Then does transfer learning improve prediction? So limitation of data features that are missing in the current data set. There's several features we think are missing, like, you don't even have gender, and we don't have medical condition of the person. We don't have many features that may influence how a person reviews a business, and the personal details are fairly minimal about the user, and we'll see that in the data model. But this may be an opportunity in the future where if we can get more details about the user, then that might be helpful, and we may find some paid access to the Yelp API wherein we're able to get a greater set of features about the user, and that might help. So when we looked at the data set, it had a bunch of categories: restaurants, shopping, homes, beauty, fitness, auto. Now, obviously, some of them are going to be weather influenced, some are going to be less influenced by weather, but we'll just have to see and we've got pretty large size of number of business in thing. So this is our pre-processing and model generation kind of flow. So we're going to combine the Yelp API and weather API. There's going to be a lot of pre-processing. We already discussed that. We're going to have some feature selection and then some derived features. And especially our NLP, we think we'll apply here to extract features from the review. And then we'll do a cross-fold validation and then run several models. Existing Kaggle notebooks have given us a good idea of some of the models that they've run and the kind of accuracies they've got. So we have a good benchmark already to see whether can actually improve that prediction accuracy. And that's how we'll be sort of evaluating ourselves. And then the model itself that we've done with the weather, we can look at the different machine learning models we use. We'll compare like RMSE, R square, and then area under curve for some of the regression type models. This is the data model. So it has these are the features about the business: name, address, city, state, postal code, latitude, longitude, stars, review count, and hours of business. And then the user has name and stars and what kind of compliment the user gives, but not really any more information about the user themselves, like gender, age, income. All these things are, we think, are very, very important factors, but they're not available to us. And then in the review, we have like the user who gave the review, the business ID, the number of stars, date, text. Is the review, did other people find the review very useful? That I think is an important criteria. And then in the weather, we have a number of features in the weather. If the weather was windy, the hot, temperature, air quality. So we think if from a significance perspective, the richness of the weather API might point out to the sparsity of data in the Yelp in terms of number of features, and it may make a case for expanding the feature set about the user and the business, so that way the weather can really start to
impacting businesses.
Yeah, we can. So then finally, once we do this, we try to learn from large data, extract knowledge from large data clusters and groups, and apply that knowledge model to improve predictions in sparse data clusters. Transfer learning can utilize knowledge from closely related training data sets and test it and apply it to a different target data set. So this is going to be a lot of learning for us in this project, where we're going to learn some advanced machine learning concepts.
How we are going to implement those things.
Yeah, so it's going to be quite challenging, but then we've gone through some of the tutorials and everything, and we've looked at data bricks. And this slide here below shows the technology platform for implementation of federated transfer learning. It starts with an open data lake house where we put all the data in there, and then you have the data versioning, then data ingestion, feature store. Then you can actually start doing something called auto ML, where you can run these models
automatically through some automated
scripts, and then we'll test the models against each other and then build. So this is going to be, we think, a fair bit of new learning for us. So thank you very much. This is the overview of our project, and we'll keep you informed as we make progress. Again, I'm Chaitanya.
I'm Babu,
and our other teammate is Vijay and Hari Shankar, and we all work together on this project and presentation. Thank you.
Thank you.